Up next, we have Victoria. Victoria is a PhD student and a graduate research assistant at North Carolina A&T State University.
Thank you so much. My name is Victoria, as she said, and I'm a graduate student from North Carolina A&T. And today I'm going to discuss or talk about transforming decision-making during disasters using knowledge graph database. Just to give a general overview of what we're looking at, I have personally experienced flood. I'm originally from Ghana. As an 8-year-old, I experienced flood in my home, and we did not have a lot of resources. We did not have what we would term as situational awareness. As a child, I saw my parents just kind of get worried. We didn't know who to call. And then, of course, we had emergency management, but we did not have enough information to make certain decisions. And this eventually, and unfortunately, my aunt actually lost her child during that particular disaster because we did not know how fast that flood was spreading and which particular road was closed or blocked and all the stuff that happened to it. And so during my research, this particular event had been like a background and a motivation. When my advisor brought this up, I decided that why don't we go with something that if we have all the information, and which is what we call the knowledge. And then through research, we found out there's a knowledge graph, which ArcGIS Enterprise has an extension. So today I'm going to talk about this. This research is between A&T and University of North Carolina, Chapel Hill. I have my advisor, Dr. Leila Hashemi-Baini, and then we have Dr. Stephanie Texera-Poit, who is also on the social work network. All right, so clearly from my initial discussion, disaster management is definitely a very complex and quite multidisciplinary, and it's a challenge that requires one, because it's something that is potentially life-saving and very dependent on time. It requires effective decision-making, efficient resource allocation. As I earlier said, there are some hospitals, there were some shelters that were very overwhelmed, and also getting to have quick and accurate decision-making processes. In terms of database management or emergency management, in terms of using big data, we see that there's a vast or a large variety of information. In case of an emergency or a crisis, there's audio, there's live feed, there are pictures. In today's world, I would typically go on Twitter and then give a tweet. And so that's unstructured data. People would take pictures, people would call emergency management. So that's a dispatch log. All of these large data are very dispersed. Some are structured, some are unstructured. And so the whole idea, and also we do have like the weather, we have transport data, which will have some live feeds, and then some are already like predetermined, some are relational, some are not. And so all we want to do is to kind of have a hub for all of these data, which we call as our knowledge in a specific domain. In this case, will be in the domain of disaster management, and then be able to move on to the next one. So even though I had my personal reason for doing this, in terms of the research focus group, the main problem was to be able to have the current information in GIS and during emergency management. What we saw, or what we, from literature review, a lot of GIS data sets are quite relational, and so you need to have that kind of manual join, look for a specific key or a parameter in a certain relational data and sort of join it. All of these things take time, especially during a disaster. Imagine you are an officer in emergency management. You have access to various kinds of data. During an emergency, if you have to go through each different kind of data or each layer, that's going to be quite a lot. And so one of our main problems that we saw was that. And then secondly, in terms of the social network side, the ability to actually retrieve this information to give emergency dispatch, to give key decision makers, even the victims during any disaster, is something that we realized that we definitely need to go through it. We had a three-phase approach. And so first, as a researcher, I wanted to know what was already there. And then if there were real gaps for my particular research. And so through literature review, we did see that, especially on the social vulnerability aspect, yes, there's a need for a comprehensive data set and something that will sort of bring all of this data and help give real-time decision makers. Then we also had a case study. We did a three-phase case study, one with certain focus groups in 5 North Carolina counties to kind of know. We started with community-based organizations because these people are also at the forefront of any disaster, to kind of know what their issues were. And they did tell us that during disasters, they did not have all the required information to make certain decisions to help the communities in these kind of situations. And then we also spoke to the emergency management. All right, so what are your challenges during disasters and how best can we help as researchers to quickly optimize the time? Because we do know that when it comes to disaster, every second actually counts. And then we went further to talk to the people in the community. So this probably would have been me if it was about 20-something years back. So we had the listening sessions too. And so through the listening sessions, we were able to determine exactly what these people were saying. Some of the challenges that I said, they had no idea what to do. All we know is that anytime there's a disaster, we all get that flash alert, like a yellow thing on our phones, but it doesn't really tell you maybe move to this side or this road is blocked at this time unless you go online. So as I earlier said, these 3 areas: physical infrastructure, critical infrastructure vulnerability, and then the social vulnerability were like the 3 building blocks in my literature review. And then as I earlier said, we found some of these gaps. We do not have a lot of literature that are extremely focused on applying knowledge graph in the area of emergency management. So this is just to, again, reiterate what I said about the problems that the main themes that emergency management spoke about. They did not have a platform that synthesized data from multiple sources needed for establishing that disaster declaration. And then we also did that from the CBOs, as I earlier said. The fact that in certain communities, there are minority and then low income, when these people actually experience disasters, the effect is very, 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 it is quite disastrous. And we also noticed that for certain counties, the 5 counties, New Pasquotank, particularly in Robeson, they actually told us that they're experiencing rural gentrification. People are moving out because they feel like during some of these emergency disasters, they cannot get access to real-time information. And so they move to other counties that they feel they'll get more information, which we do not want. So yes, we started this research kind of looking for some hotspot areas and then doing a preliminary vulnerable assessment. The main goal of this, the overall goal of the research, is to spread this, to have a holistic GIS data set stored in a particular knowledge database, and then for the entire North Carolina. But we're in the preliminary stage of the research. And so we started off with 5 counties in North Carolina: Edgecombe, Pasquotank, Robeson, Brunswick, New Hanover, these counties for now. So just to, again, as I earlier said, just to give some context to some of the reasons why we selected these counties currently. We believe that, and also from research, and also from what we could see, Hurricane Florence actually devastated some of these particular counties. Matthew was also a big disaster in Brunswick, and then Edgecombe. I've been saying this through and through, but just to add that the whole goal is to provide a detailed assessment of the hotspot areas, something that once you click on there, it's not in a particular shapefile or relational base. You have it on a particular app. If you click on a specific area or zoom on a specific area, you have detailed information of who is involved, where is the nearest, or how close are you to a nearest emergency or shelter facility, or even a health facility, and all of those information about a specific either individual, a household, or even to zoom out to a particular census tract or a block group. Some of our justification for using the knowledge graph or a graph database is that currently using the traditional databases, it's not too flexible for you to have a specific schema in. The traditional database, it's focused on, it's quite rigid in just one particular area or one schema. But using the knowledge graph, you can have multiple schemas. And fortunately, our GIS knowledge gives a very good flexibility to merge all of these schemas in. And then in terms of context, once you have a table kind of data, the context is not too specific, but using a knowledge graph, and I would explain as we move on, we have something we call the ontologies. You're able to give it a context. And this comes from the natural language processing, which we are used to in today's world. And so any specific word or any specific idea or entity that you'll be looking for, because in a knowledge graph, you have the NLP in it, it's able to actually give you more accurate result than that of a traditional database. And also imagine having all the shapefiles in North Carolina, and you're looking for a specific household or a block group. That's going to take a lot of time. But the knowledge graph has proven that you can have all of these in a centralized system, and within a matter of seconds, you're able to locate the exact place. So you don't have to go through multiple files. So just breaking the term knowledge graph, we have the knowledge and then we have a graph. So I'll start with the knowledge. The knowledge is just a set of information in a particular domain or a particular industry. And so you have all the words, anything within particular domain or industry will be like a knowledge. Then a graph is just a visual representation of your data. And so every graph has a vertex, which is like a point, and then the relation between the graph is what we call the edge. And so this is exactly how we are proposing to present our data in this particular visual, and then layer it on a map, which we will see at a point in my presentation. Now, our GIS knowledge on the enterprise is the main software we are using. And yes. So in constructing a knowledge graph, I believe the previous session before the break, and also one from Ms. Susan, actually gave us an idea on some of the benefits of using the enterprise. And so the ArcGIS Enterprise has a hosted graph store, and then you could also use either of these two third-party database management to store your data. And so in my presentation moving forward, I would just demonstrate using the Neo4j, but my research is using both the Python API that you connect through the knowledge graph enterprise server, and then Neo4j. And then once I am done, I'll compare to see the accuracy and then the quality of my results. Now, I would like to highlight again that this particular research, we're still in the initial stage of this research, but moving forward, we are very optimistic that we will be able to get very good results for our users. So, as I spoke in my previous slide, the vertices of a graph in this case will be an entity or a node. And then the edges of a graph are the relationships. And so just giving an example, if we're using this particular conference, we could model it as a graph. And so this particular conference will be an entity, and then we could have all of the individuals in all the participants as also entities, and then the relationship or the edges will be attended. And so that's a very nice way of just visualizing everybody. And again, it's also having all of the data in. And so we'll have multiple edges. It'll probably be like a spiral one. I just brought that Python code just to show if anybody's interested in how to connect from the Python API. It gave me quite a little bit of a tough time. But the main architecture or the framework that we're working with is, all of this is definitely in the ArcGIS knowledge enterprise, but we are doing like a bi-directional research. One, we go to the users, which are what I said, the community base, the victims, and then we would do our analysis and then go into where our analysis is in the graph database. But again, whatever our result is, we take it back to our users. If it's not exactly what it is, or if the implementation is not as good as we want, we go back to it. And so we start with end users, we will come back to them as the final output. So that's how come my framework is very bi-directional. Our data set for consideration are data set from the built environment. And so bridge locations, we have the road locations. We also look at the natural environment. And all of this is just to show you how diverse you can ingest various kind of data in any graph database, specifically the ArcGIS knowledge. We have hazard response, and we're using data from FEMA hazard for their flood boundaries. And then for social economic demographics, we're using data, the social vulnerability scores. We are partnering with RTI to use their synthetic population, and also kind of make our own analysis of spatial distributions of these socioeconomic aspects. And so an initial framework that we are working with, to the right of this particular slide, is like an example as I gave. We can have a node, which will be the conference or this particular session. And then every individual in this session will also be another node, and then the connection or the edge will be attended, or it's seated right here. When it comes to the relationship, they are usually verbs or they are usually words. But the good thing about these relationships is you can assign properties or attributes to the node and also attribute to the relations. And so an example for a synthetic population, we have the person IDs as our entities. We have the gauge from Feynman T, road segment, the particular segment of the road that is being affected by any disaster, in this case, which would be the flood. Then we have the building footprint, which is very important. The household point, we have data from the rarity, which is also on helping to know the health, data on health and certain social demographic information of these particular, either a block group, a census tract, or an individual. And then we chose schools, workplaces, hospitals, shelter, any of these critical infrastructures that we need in any society. And so just to give you how a knowledge graph very simplified 1 point how a knowledge graph looks like. If we have the road segment, we can start from the person ID. Now the person attends a school, and if you assign properties to the attending, it will give maybe the time frame in which the person attended that school, the year. You can assign that as a property. We have the lives in a particular area. We have road segments that will show where the flood has affected, and that will be the impact relationship. Then we have what we call the evacuation path, which is where there's no flood. And so the individual can actually use that area. And all, just to give you an idea of how the knowledge graph looks like. So as I earlier said, these are our data sets, FAM&T. We're also considering the natural land cover in floodplain in all of these counties, as I earlier mentioned. Very, very important for us to use. In our GIS enterprise, the knowledge is an extension. And so that means that if you do not have the license, you can still use a pro, you launch it as a pro, but you cannot have the knowledge function. This is to show how it looks like from the beginning. If you are to ingest the data in, it's able to automatically pick the entities and also have the relations that you want. And then from here, you're able to do very good analysis, you're able to query it, you're able to ask certain questions. In between my data collection and my analysis, thankfully, I have one good news and one bad news. The good news is that Esri has updated this particular software from 11.0 to 11.1, obviously, so that we can have more and more resources on it. But you need 2 different licenses for it, and that is where the enterprise itself and then the user license. In between it, some of our data analysis got lost, but like I said, this is still a preliminary stage, which is the bad news. We are still in the preliminary stage. This was previous analysis that I did, and so we do know that the ArcGIS knowledge is, that extension is a really powerful tool that we'll be able to use. We're still working with the software developers at Esri to kind of jump us onto the 11.1 as quickly as possible, so we'll be able to do our analysis perfectly. So I said that we could use either connecting through the Python API or the Neo4j. So I'll start with the Neo4j. Just imagine a scenario where you're dealing with a flood event in a specific area, say Pasquotank, New Pasquotank, or Edgecombe County. We just want to show how a graph database will help you create a detailed representation of this particular scenario. So the structure that we are working with is very simple. We'll have a flood event as a node, and then we'll have, and this particular node will have some properties like what is the name of that flood, or if it's a hurricane, we have names for it, or even if it doesn't have a name, it's just flood and give it a special ID. Then we have the dates that that particular thing is happening. You can actually put a timestamp on that too. And then the specific counties that that flood is either predicted to affect or it is affecting, you can use it in both ways. Then you can create the relations in there. So the knowledge graph is the next figure on there. We can see that this particular flood, which has all of these nodes around it. We have the road, it's a highway 70, and then we have the I-40. So we're able to determine, if we zoom down, we're able to determine which part of the highway is flooded, and it gives you more properties or more attributes. And so you can say, all right, this is where I want to turn. And the good thing is that it actually shows you some of the exits that you need to take if you want to avoid a flooded zone. All right, so just to bring all that I've said in, and like I said, this is an initial research or preliminary results that we are doing. It's just to prick your interest in hopping onto the enterprise and probably using the knowledge graph part. We have seen from a small user case in our analysis that the knowledge graph definitely has a good potential to impact communities. And just to give how the output will look like, you are able to connect that particular result to a simple app, very open source. You don't have to sign up to anything. And this app will be available to the users or the victims, that they're able to not just get a simple trigger alert, but they are able to actually know where they should go, which particular hospital or shelter unit, which part of the road is good, which is something that I wish I had. Hoping that this approach will be a standard method for the North Carolina emergency management, because obviously they are our main goal, and we also listen to them. We are hoping that our results will be able to provide real-time mid and also post-event analysis. And then we are hoping that we can improve on the current problem of rural gentrification if we're able to give our result to key stakeholders in these counties, and even to the North Carolina government. They're able to make more decisions for underdeserved communities. These are some of our references that we use for the literature review and also to help with understanding our analysis and our model. Thank you so much, and I'll take any questions that anybody has now. All right, thank you so much.